started. Don't mind my mess in the background. Um, but today I think we're going to talk about carabiners, rope. So basically just connectors and styles of rope, trying to understand what the differences between some of those things are and um, I guess how to pick good materials for what you want to do. Feel free to jump in at any time with any questions that you have, and just let me know if there's anything that I can answer for you, or if there's a topic that maybe I can help bring up. All right, cool. Um, all right, so I'm going to get started with ropes first, and then we'll move into hard gear. So we'll break this out into soft gear and then hard gear. Um, I've got a couple of different ropes here, and mostly these are just segments as examples. In caving, what we normally use tends to be static rope. So this is just an example of a piece of static rope, and it's been ended here pretty well, melted. And I guess I could break off one of the ends to kind of demonstrate what the term kern mantle means. So um, part of let me go back a little bit. In caving, we like to use static rope because we are climbing the rope itself. So it's single rope technique. And part of the reason why we want a static rope for that is um, it won't stretch as we're climbing it. Whereas if you had dynamic rope is often used in like the rock climbing world, and they're actively taking falls on this style of rope, right? So it's got some stretch to it. You would have to read the manufacturer's spec in order to get some information about it that explains, hey, it was static, or hey, it was dynamic, and this dynamic rope was rated for 7 falls of X number of kilonewtons, right? So do save and read your manufacturer's spec on your rope. But let me see if I can peel the end of this a little bit and we can examine it. Um, in the world of uh, this style of rope, what we're looking for is something called kern mantle, and it comes from German. Basically, it's uh, the outer sheath of the rope is a mantle, and the kern is the core. And basically, the rope is composed of, wow, this is ended pretty well. I might need to cut it. Um, Let me go cut this. All right, so now we've got the end of the rope is cut here. And so what you can see with this is that it's got this braided sheath. That's the tough layer on the outside of the rope, and it's meant to protect all of these fibers on the inside, which is the core. Now, if I can peel this down a little bit, what we'll see is that those core strands, um, you can see them there. They're pretty straight. It's made out of nylon. In the caving world, we like nylon because nylon tends to be um, nice and strong. It's like I work in plastics for bottles and stuff like that. And when we need a plastic that will preserve the integrity of our product in the bottle, we often use nylon because nylon is a good barrier layer. It prevents like air absorption, liquid escape from the product and stuff like that. So caving rope tends to be made out of nylon, and you can see there's all these coarse strands on the inside. So that's the kern. And then the mantle is this braided sheath out here that's protecting that core. Generally, in caving rope, we consider the core to be about 70% of the strength of the rope itself, and the sheath is considered about 30% of the strength. So the outer um, sheath actually provides some strength as well as protecting those inner fibers. But what you'll notice is that these strands are all nice and straight. That's different from, say, something like a braided rope. If this was braided, you would get a little bit of spin. What is the purpose of semi-static rope? That's a great question. Semi-static rope actually exists for purposes like in European style rigging, when we do things like a lot of rebelays or um, a little bit more of that technical style rigging, um, you're you're getting a little bit of stretch on that, and part of the reason why is because the more frequent anchors that you're having um, sort of need that little bit of extra stretch. We don't want to be falling on single rope technique, but basically, if you were to um, have an anchor blow or something like that, it provides a little bit of a safety factor there because if you were to fall on a fully static rope, you basically would end up with no stretch, and so your body is taking all of that impact. If that sort of makes sense. So there's a time and a place for semi-static rope. It's not super easy to climb, right? So like if you did like a bunch of like throw and go kind of rigging, you're probably going to want something a little bit more like the traditional American pit rope. American pit rope is great for that because you're just throwing it over the edge and it's got this highly durable sheath. We're going to rope pad it, of course. And it's great for long pitches. If I'm climbing like Ellison's fantastic pit, I'm going to want something that has very, very low stretch because I don't want to have like have to fight it like it's a rubber band while you're climbing it. But if you're in the situation where you have a lot of rebelays and things like that, where there's anchors that might have some sort of a failure factor there, you might end up wanting something a little bit more semi-static. So that's why semi-static exists. Yep. So there's a lot of good options for static rope. Again, it just comes down to like manufacturer specifications and things like that. This looks like it's PMI rope actually, because I found a tracer tag in it. And so some of the manufacturers will put a tracer tag, and you can see that there's this little, it looks like dental floss in there, but it's got some printing on it. Right now, what it says is for life safety. If I were to continue to pull this tracer tag, it probably has the date of manufacture and a little bit more information like that. It's sort of like they're tracking if something were to fail, you could send a piece of rope back and they could figure out what was wrong with it. So um, anyway, this is an example of an 11 mil static rope. Static rope doesn't have to be white. You can buy the outer sheath in other colors as well. So I know cavers like white rope because easy to see, easy to clean, I guess. Colors and just side note, since I work in plastics manufacturing, uh, colorants are considered contaminants in their own way. They're additives effectively, and the virgin plastic will be sort of a white or a clear sort of color. So just a side note there. Now, cavers typically use anywhere from, I've lost my other sample, um, anywhere from 9 mil to 11 mil rope. So I don't know if you guys can see that very clearly over the camera. Um, but basically, we've got a 9 mil rope here and an 11 mil rope here. And when you put them side by side, you can kind of see the difference there. But basically, those are generally the diameters that we're using. Part of that is because of how like our hard gear tends to be accepting of these kinds of diameters. Um, Firefighting tends to use like a 13 mil rope that's a lot thicker than this 11 mil here. But again, uh, generally the range that we're working in right here. Now, if you are going to use something like 9 mil rope, you're going to want to inspect it a little more frequently, right? You should always be inspecting your ropes before and after use. But 9 mil, just being a little bit thinner, might be something that, takes a little bit more abrasion. And again, this comes down to reading your manufacturer's specs. Dynamic rope, we like to use this stuff for like cow's tails. So the theory behind having a dynamic rope for your cow's tail is to have that little bit of stretch. Again, we don't want to be falling at all during SRT because, it's a short place to be taking any sort of impact. But traditionally, we use dynamic rope for two reasons, actually, when we're building cow's tails. One is it does provide that little bit of stretch, but the other is that I finally got a good explanation for this when I asked quite a few people. The outer sheath of a dynamic piece of rope tends to be built a little bit more with the consciousness of rock climbing involved. And so when you buy a dynamic rope for your cow's tail, kind of think about that, right? Like if you buy gym rope, it's designed for an indoor setting. But if you buy outdoor climbing rope, it's been designed for taking wet conditions and has a very strong outer sheath for abrasion and stuff like that. So it's good to actually kind of take a look at the manufacturer's spec of the dynamic rope that you are buying for your cow's tail, because one of the main advantages of being able to buy a piece of dynamic rope for your cow's tail is to look at that outer sheath, look at what kinds of coatings they're putting on it, looking at what kind of uh, stretch ratios and other things like that. So that was something that I finally got like a pretty decent answer. Like, why dynamic? Well, it turns out two reasons. One, you want that stretch on your personal gear, and two, it's that outer sheath for outdoor rock climbing rope tends to be built for very, very harsh conditions, and that can be an advantage in that scenario as well. If anybody knows of any other, add-ons to anything, feel free to also jump in. And again, similar to how that piece of static rope is built with the, kern mantle, the inner and outer, the core and the sheath, dynamic rope is built in that very similar way. Couple of other interesting tidbits that I have. So I've got this very old piece of rope here. This was actually 40-year-old rope that was removed from Lechuguilla. And Derek Bristol actually has a video of him putting this on a pull test that he designed at home. He has an Instron machine, and he pulls this rope. And despite being in cave for about 40 years and under some weathering conditions, you can see how stiff this has become over time. The overall strength of this particular piece from Lechuguilla is actually pretty close to the original break strength that was on the manufacturer spec for it. So that's kind of an interesting little tidbit. Of course, you would want to be checking, the conditions of your individual cave, right? If there's a very acidic environment or perhaps certain bacteria, you judge that on a case by case basis. But this is just an interesting piece right here. You can again see how weathered and stiff this has become, but just a little interesting piece of history there. Now on to a couple of other interesting things, right? When we inspect our ropes, we typically want to like be giving it this bend, right? So we want it to bend like this. We see there's this nice curve. It should kind of like flow in your hands. So when you're using your rope, again, you want to inspect it, right? Before and after you use it. That way you know everything's still safe. And, this is my good piece of static that I for demo, right? You see this nice curvature and bend. So when you're inspecting your rope, you want to feel it on the outside to see if there's any damage to the sheath, and do this bend for each segment as you're going along. So you're gonna, feel and bend and feel and bend as you're going along your rope to inspect it. Now there's something that's called a core shot, and um, I have an example of a rope that's very badly core shot, right? So as I'm doing my feel and bend, oops, the inside core of this rope is broken. So the sheath can look perfectly fine. Here's another core shot rope. And the sheath can have that little bit of fuzz. This isn't, that's an acceptable amount of fuzz. And this is a deliberately core shot rope. This didn't come from an accident. We core shot it on purpose using a little tool driven into it to kind of give an example. But as I'm doing my rope inspection, you can see I've got that nice bend right here. It flows through my hands. I go to the next segment and you see this little bend here, and it feels weird. Something's wrong. It hangs up right there, and that's something you want to just feel around, and you're like, oh wait, there's actually something wrong with that, right? So you don't want to be using those core shot pieces of rope. That's a place where you want to maybe cut that, and now you have two smaller ropes, or maybe you just retire the rope completely, right? Because we talked about how 70% of the rope's strength comes from that inner core, and about 30% of it's coming from that outer sheath. um, I really wouldn't want to be using something that's separated like that, right? So, what's one of the ways that cavers, if you were, mid pitch and you're like, oh no, I found a core shot in my rope and I need to get out of here. One of the things you might do is put an alpine butterfly on your rope and isolate that outside of, the rope. So now you would have to pass a knot. Um, and knowing how to pass a knot without clipping into this loop for an alpine butterfly. Your other option is, if you know how to tie a double alpine butterfly, we can tie a double alpine butterfly, and then you can clip into it, because you would clip into both strands and you would have 100% strength in one of the ears of that alpine butterfly and the other remaining strength of this. So just don't even think about it, clip into both, right? If you can tie a double alpine butterfly. Let me go grab a piece of rope, because I'm on this train of thought here, and I will show you guys how to do that. All right. So alpine butterfly, right? There's two different ways to do it. There's the hand wrap method and there's the twist method. So if I was to do the twist method, you do two twists, right? The top of this top head is the head of the snowman. My thumb is in the body, and then it's got two legs. Um, the head goes between the legs. I maintain my thumb through that body and through the head that just came down. And it goes between the legs and up his butt. And that's your alpine butterfly. It's set and dressed now. And basically you could isolate that core shot here and continue on your way. Consider retiring that rope afterwards, obviously. The other way to tie an alpine butterfly is the hand wrap method. So we would wrap 1, 2, 3 around my hand. I'm going to go under this top strand, pick the middle one. So I've got the loop right there. I'm going to go over the two strands that are still on my hand, and then push it between where my hand used to be. And there you've got an alpine butterfly again. Now, if you wanted to do the double alpine butterfly, instead of wrapping my hand 3 times, I'm going to wrap it 4 times. So 1, 2, 3, 4. I'm going to go under that upper strand, pick the middle 2, and then do the same thing where it goes over the 2 remaining strands that were on your hand and push those middle 2 back through the hole. And now you have a double alpine butterfly. Set and dress it by pulling the 2 legs, right? Come on. Made my ears a little small here. But effectively, what that does is it allows you to isolate your core shot on one of them and then have another ear that you just clip into both of these and pass the knot the easy way. So that's just a little trick to help with that. How do you check ropes that remain in cave for that kind of damage? Yeah, so if you were rappelling that or trying to climb that where you found a core shot like this one looks pretty obvious, right? Like if I saw this, maybe a rat chewed it, that happens in cave. Maybe it got damaged against a rock that was rubbing up against it. The other thing that's really common that causes a core shot is when like a rock falls onto a piece of rope and like it damages it. And there's actually enough force that comes from a rock fall that can damage rope. Um, but if you were rappelling a rope that had a core shot, you'll be rappelling and it's nice and smooth, and then ka-chunk, you feel like this little chunk that happens through it, and then you're gonna look at it and be like, uh-oh. Um, the other thing might be you're climbing up to it, and similarly, as your ascender goes over it, you're gonna feel something's wrong right there. That's definitely not the way you want to be finding it. So like for perma-rigged caves, that is something that you have to be a little bit cautious of. Um, but the best thing to do is to do your rope inspections, if you can do them. So I don't have a great answer for that other than like if it was perma rigged and something happened and we didn't know about it, and you're like the first one down who found it or like something like that. You know, Chad McCain has a really great video that he posted or a picture of it that he encountered this year in a perma rigged cave, where he I think had a de-sheathed rope actually where the core strands were sticking out. It's still maintaining some form of strength, but um, you definitely want to fix it. So in his case, he did isolate it with a uh, alpine butterfly, and then moved on from there to fix it. So, um, what is this question here? It says, why would a single alpine butterfly be recommended for a damaged portion of rope when crossing the knot is going to require attaching to a loop to cross it? Um, it doesn't always require that. There's actually multiple ways to cross a knot. So it's a matter of skill, right? So if we can tie a double alpine butterfly, go ahead and do that. It's not a common knot. A lot of people don't know how to do the double alpine butterfly. Um, but if you know how to do it, absolutely, like use it so that there's a good location to clip into. But it is a little bit more common to see a single alpine butterfly used for um, isolating a bad piece of rope. So be careful of that if you are climbing a perma-rigged rope that you found one of those in, right? You don't want to clip into it immediately unless you know that it's safe. If you know that it's got a core shot in it, you don't want to be clipping into that at all. But knowing how to pass a knot without clipping into the knot itself is actually one of the entry skills for I think level 3 NCRC. And there's multiple right ways to do it, right? So if you had, for instance, a QAS, that's probably one of the easier ways to do it. You basically turn your frog system into a Texas system and you put two hand ascenders on, and then you can, climb up a little bit and then get your curl over the knot. The another way to do it might be if you are carrying like a micro traction or a T block or a roll and lock or one of those other sorts of extra handy devices. You could clip that onto the rope and clip your short cow's tail into that. And that becomes, again, like a Texas where you have two hand ascenders on the rope and then you move your curl over it. Um, Another way to do it might be um, a Prusik, a pulley. But basically, there's a couple of right ways to do passing a knot without clipping into the loop. Similarly, you might even clove hitch the rope and around your short cow's tail. Um, and then that's your anchor point as you pass the knot. Um, Passing the knot on the way down, similarly, you would just rappel right onto the knot, assuming, you're not, uh, you know, you would rappel right onto the knot and then, put your ascending gear on, move your rappel device below it, and then go from there. So, yeah, 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 yeah. So, but when you pass the knot on the way down, you rappel onto it. Um, you would put your ascending gear on and then move your descent device under the knot and then, do your test rappel and then keep going. Now, of course, this all depends on like what direction are you headed, right? Because if there's damaged rope, do we, how many hours are we in on this cave trip? Do we want to like maybe call it quits when we find that knot and the damage and maybe leave, get a better rope and re-rig it, right? So there's options. There's always choices to be made. So cool. Um so that's a little bit on core shots. Similarly, you might find a rope that gets desheathed where, we're now exposing those inner strands. Um, that can be tricky, right? Like if you're repelling that, that can be really problematic because what might happen, you might start repelling down something that's got its sheath exposed, and then you're just yanking that sheath down with you, right? So that's not a great situation to be in where you have like a desheathed rope. So similarly, you might want to like change over and figure about trying to, re-rig that instead. Um, if you came upon a desheathed rope on climb, that's also another challenge, right? Because now we've got all these like strandy things that we're trying to climb, and all of our modern ascenders have teeth, and our teeth may not want to actually grip into that, right? So uh, that goes back to the, Prusik is a very handy tool. A Prusik will kind of grab around that. The other thing that does like to grab on that is like a Gibbs ascender, or like Roland locks have those Gibbs style grooves. Those actually, like, this is coming from personal experience, having experimented on like 5 feet off the ground on a desheathed rope. Prusik will help you get over that. So like situations you never want to be in, where you're trying to climb a desheathed rope, but like uh, finding a good way to like escape the situation, right? So anyway, so that's a little bit about desheathing and core shots. Um, Let me go. I'm going down my line of uh, bad ropes here. So this one is there a max or min millimeter cord for Pro6? Great question. Pro6 cord, uh, there's a little calculation that the book on rope calls out for Pro6 cords. And basically it looks at the diameter of the rope that you're working with. So if I'm working with 11 mil rope, um, the calculation is basically diameter of your rope minus 3 millimeters. So if I'm working with 11 millimeter rope, an 8 millimeter Prusik would be appropriate for it. Now, what I like to tell people though is try that out, right? So if I buy an 8 mil prusik and I'm trying to climb an 11 mil rope, I personally am a 5'2", 130-pound person. Um, and what I have found is that an 8 mil prusik on 11 mil rope, I slip a little bit on if it's my personal prusik and I'm just gonna try to climb it myself. Um, 6 mil prusiks have worked pretty good for me. Um, the thing that you want to use for prusik cord is dynamic cord. So think about uh, shopping for a dynamic cord for it. The other thing to note is people have like buzzword these days, right? Dyneema. Everybody wants Dyneema because it's hella strong, right? And I actually have a piece of Dyneema here. So here's a piece of Dyneema. It's white. This is dirty, so it's not white, but this stuff's super, super strong and kind of hollow fibered and stuff, right? So very lightweight, very strong. Um, Folks are like, well, why can't I just use Dyneema for my Prusik? Well, Dyneema actually, if you go read their spec sheet, like specifically calls out, like, please do not use this for a friction hitch. And the reason why is Dyneema has a very, very low melting point, and a Prusik is a friction hitch. It's holding the rope using friction. And basically, what you don't want to do is use something that has a very low melting point for friction because it will melt. So Dyneema actually calls it out in its own spec sheet, like, please do not use this for any sort of friction hitch. But Prusik cord, um, I have found that 6 millimeter for personal climbing use has worked out well for me. But generally, the rule is diameter of the rope minus 3 millimeters is uh, good use, basically. 8 millimeter, and again, when you buy like a 6 millimeter Persic cord, you want to read the spec sheet of that cord to say like, oh yes, it's dynamic, and also it's rated for like holding my weight and my strength, and like you want to see how many kilonewtons it's actually rated for. So that's word of advice there, right? Read the spec sheets. But 8 mil cord on an 11 mil rope works great for like a rescue load, for example. Um, but yep. Um, then the next piece of rope that I've got here out of my damaged pieces of rope is a glazed piece, and this may be a little hard to see on the camera, but if you look right there, you'll see like there's like a stripe going down this rope where the term glazed means you repelled it so fast that it actually melted it a little bit. So you can see like a little bit of glazing on that rope right there where it melted the outer sheath of this rope, and it's actually quite crunchy in that spot where it got melted. So um, this is a phenomena that happens when your repel device is getting really hot because you're repelling it super fast. So I am personally a slow repeller. I don't love the thrill or the speed. Like, it's a technique that I learned because I wanted to get places. But there are thrill seekers out there, and somebody made me aware this past weekend of a YouTuber who went to Bridge Day and has been bragging about like doing a 2 minute rappel down 800 feet, and kind of not cool, guys. Like you glazed the rope with how fast you went, and that costs a lot of money. So whoever bought the rope, like they lost a lot of money right there. So anyway, um anyway, that glazing a rope, um really it's creating this hard spot where it's melted the rope sheath. Now, we talked about how the core holds about 70% of the strength and the sheath holds about 30%. So not necessarily directly life threatening, but the next person who ends up repelling this is going to end up having a really fast ride down this glazed portion, right? So you're creating an unsafe situation for the person after you. So while you may not have, experienced anything horrible, but like, and the rope hasn't lost strength, you're going to have this situation where you're running down this smoothed out section, and that can be pretty speedy for the next person, right? So you're going to inspect your ropes, and if you do find this glazing, again, it might be something you want to retire your ropes over because you've, for one, damaged the sheath, but two, um, it may not give an ideal ride going down the segments that got melted like that. So um, anyway, consider that when you're inspecting your ropes as well. Um, couple of junk ropes to show, right? So this is some Walmart rope here, boat rope. I unfortunately have seen this style yellow rope like put into cave before, by somebody not exactly educated, and that's not great because this stuff isn't like strength rated for anything. You can see it's just sort of braided. There's no core. Again, read your spec sheets. This guy probably doesn't have much in the way of like a spec sheet. So go into your regular hardware store and buying this stuff doesn't have the same rating as what um a caver rope might actually have. It may be convenient to buy, but here's a piece of rope from Walmart. And while it looks like it's a kern mantle rope because it's got this outer sheath and then an inner core, if you actually pull the core apart, these are plastic fibers. I can't tell you if it's nylon. You can see it's not not braided, but like they're just like loose fibers versus if you look at my actual PMI rope here, you can see there's some weaving going on there. There's some stuff going on. But this is plastic fiber, but then you get to the rest of the core and that's tissue paper. Right. So I don't, they made it the right diameter, but shoot, when you open it up, I don't exactly want to be repelling on this stuff. Right. So just kind of consider that like that's literal tissue paper right there, if you can see it. So think about that, when when you get some Walmart rope, stuff first off isn't exactly rated, but when you cut it open, it's really nothing in there. Um, and then the other thing, so we talked about kern mantle. The other style of rope that exists in the world is braided. And so you can see how the inner core here has a braid. Again, like I don't know what the rating of this stuff is. It's hardware store stuff, but you can see how the inner core here just has a bunch of strands that got braided together. This, if even if it was rated for like cave work, this would be really spinny. You would just be spinning around as you're repelling it because you've got a bunch of braiding going on in there. So anyway, uh, get good rope, read the specs. That's all I've got on that. Um, Another cool thing that is coming onto the market these days. This stuff is coming from PMI. This is a Kevlar rope. Um, and it's got a well, I can't tell you about this one in particular, but I own a piece of this is Kevlar on the outside and has Dyneema on the core. This stuff is amazing. This is a 7 mil rope. PMI sells this. It's kind of expensive actually. So I've got a 50-foot segment here that works just like rope, but you can see how this is 50 feet and it packs down to almost nothing. So this is good like push rope, or in cave, stuff that I can carry for emergency situations, right? So just something that's cool and new on the market that PMI's got out there. It repels really nicely. It is a little thin, so I've had to get used to that. But the other thing is it climbs really nicely. So super super strong. with the fact that it's got a Kevlar sheath, static because it's got a Dyneema in the core, but new to the market. So technology is still improving with rope manufacturers. Do I have anything else in terms of rope? Not really. Do you guys have any other questions on rope? I'm gonna move into like cords. So we already talked about Dyneema, and I showed you a little piece of Dyneema. And so that's again super strong, but super low melt point, right? So that's something to be conscious of. Makes great rigging for like threads and stuff like that. If you were to do, a thread around a natural anchor or through a hole in cave rock, again, evaluate your anchors before you do that. But that's a super great material. A few other materials that exist. I'm gonna move into talking about cords real quick. This used to be my push cord before I had that 50 foot of Dyneema stuff. This is a static 7 mil cord. This is only 30 feet of it. Kind of heavy compared to the other stuff now that I think about it, but another option for a cord. This is a really dirty Prusik. But this is one of the Prusiks that I carry around. It's a 6 mil personal Prusik, dynamic cord. And then in terms of another option for Prusiks, this is called a hollow block. Sterling makes it. What makes it really nice is this is another option for Prusik, but it's sewn, which gives it a little bit more strength. And it's called a hollow block because it's hollow. And so when it goes around the rope, it compresses. And so it gives it that effect of being dynamic. But it compresses really nicely around it and gives a really good grip point for that reason. So Sterling makes these hollow block. I like this because it gives like a great grip on Prusik. Couple other like flat options, right? So we talked about Dyneema. This is a Dyneema sling. It doesn't look like much because you see how thin it is, but it's super strong. And let me see if my tag is not faded enough. Let's see. I believe these are 22 kilonewtons, but I would have to read the tag. But effectively, the thing to kind of know about this is sewn sling, basically super duper strong. The big thing to know is use it appropriately around the types of anchors that you know how to rig. A nice thing about or sorry, something to know about like how strong things are, right? Kilonewton's approximately like 200 pounds. So like in my brain, I think to myself, like 1 kilonewton equals 1 human. And so when we talk about like, hey, my carabiner is rated for 27 kilonewtons, then it gives me a proportion in my head. I'm like, okay, that gives me a little confidence here. Like I know what that means. So that's just a quick way to kind of think about that. Other options for slings, they have sewn webbing slings. So this is a big old piece of webbing sewn into a sling. A little bit thicker than that Dyneema one. So like visually, this makes people feel good because it's nice and thick. Rating wise, I actually think the Dyneema is actually rated a little stronger still, but I keep these around as well because beefy makes people feel confident. And then of course there's webbing, right? So we've got webbing is nice and we can do a lot of things with this as well. So just options. Webbings are often cheaper, static, and can be used for anchor interfaces rather than using rope directly in that anchor. So just something to think about for usage. All right. Any other questions or concerns or on soft gear? Anything you've been wondering about, or you've seen it in the market and you're like, what is that? How do I do something with that? Okay. If not, I guess I'll move into some hardware items and we'll talk about different types of carabiners and different shapes and what they're all used for. So, in the world of carabiners, we've got things that are lockers and non-lockers, right? So I've got here's this example of a non-locking carabiner, and then I've got an example of like a locking carabiner. So that's the difference between the two. Is I can lock the gate on this. Um, this is a non-locker, so I can't lock a gate on it. But still, if you read the rating strength, so I've got this is a Camp Nano. And so these are lightweight, like rock climbing sort of thing. And uh, Chelsea asked a question about soft gear. For lack of better words, does the diameter of a cow's tail really matter? In my opinion, yes. Um, I will also say that NCRC requires a 10 millimeter cow's tail and up if that gives you a benchmark. So 10 millimeters is sort of a good size for it. Um, but um, think about it this way. I've seen certain cave gear manufacturers selling 7 mil cow's tails. That's awful thin. 7 mil looks like this, right? I'm hanging my whole life and weight on it. Is it rated for that? Yes. I mean, we've got kilonewton, like you can read the kilonewton rating on it, and it's rated for more than 1 kilonewton, obviously, right? So it holds a human's weight. But this doesn't give me a lot of warm and fuzzies in terms of like, hey, this rubbed against a piece of rock, and I'm a little worried about that getting pinched. Whereas like a nice 10 mil piece of, ooh, where's my, yeah. So this rope, this orange rope here is actually a rope that I use to cut people cow's tails. And this is a 9.8. This gives me a little bit more warm and fuzzy, like this is nice and strong. This is actually a Petzl Volta. I also will use like Edelrid Heron for cow's tails, but I, r- I guess the thing for me is it's your risk factor on it. To me, like 10 mil gives me nice warm and fuzzies because if I see this rub up against some rock, I've got a little bit more to wear through than a 7 mil rope. Because well, where is the 7 mil rope now? But if I look at the diameter difference on that, this one gives me a little more warm and fuzzy. That's all. Um, so that's sort of answer it. I also don't mind if you guys want to go like off mute and just like talk. Yeah. Okay, cool. Um, but yeah, like 10 mil kind of standard on that kind of stuff. So we've got non-locking and locking carabiners. Really, if I look at the strength rating on this, I've this non-locker, I've got a 21 kilonewtons along the spine. There's 8 kilonewtons crossed and 9 with gate open. It doesn't tell you anything about on the gate, right? We don't super want to be doing that anyway. But the one thing to kind of look at with carabiners is the strongest part of the carabiner is down its spine. And you can see where, this is a solid piece of metal here, whereas the opening of the carabiner, this one's a little gritty. Um, Inherently with an opening there, this is going to be um, a weak point. versus this solid piece of metal here. Um, so we'll talk a little bit about carabiner strength here for a moment. So this rating along the spine here for most carabiners, you can read it off the carabiner itself. I mean, this one says 22 kilonewtons, I believe, as well. Where am I? Trying to read it upside down. 27 kilonewtons along this spine, right? So that's my strongest portion. And generally we consider D carabiners, this is considered a D shape carabiner, to be one of the strongest shapes because my rope is going to naturally want to sit at these points here. And you can kind of look at the wear on this carabiner. As a red carabiner, you can see where it's worn off the ink. But naturally your rope wants to sit here and here, right? So if you had knots on this, or, this was sitting in an anchor, that's naturally where everything wants to sit. So everything naturally sits with all of the strength along the spine on a D carabiner. Um, and that's its strongest position. One of the things that we don't necessarily want to do is tri-load a carabiner. And so what that would look like is, you've got the anchor points. Say you had like a piece of webbing and you did a basket hitch, and the two ends of the basket hitch are pulling on this and your rope is coming off of this. That's called tri-loading, and carabiners super don't like to be loaded in three directions like that, right? So um if you've ever seen, there's like this failure mode, there's photos where like the carabiner nose, like this nose here has like bent outwards. um that's sort of where that comes from. And if you read the manufacturer booklets on this, they'll talk about that as well, where they're like, don't do the tri-load. So you want, if you do have that basket hitch, you kind of want to land both ends of that basket kind of in here if you can, right? Not too hard to do. Now that's your D carabiner right there. Um, and uh, again, it likes to load everything along the spine. It's super great for that, but it doesn't always have that best usage, right? If I had that basket hitch and it ends up tri-loading it, you might have a problem there. But that's where sort of like the oval carabiner comes in. And what is my break strength on this? This one's 25, right? And the difference between 27 and 25 in the end isn't super duper huge, right? So in the end, yeah, an oval carabiner, uh it isn't necessarily as strong as a D carabiner. Okay, fine, but it's still super duper strong, right? 25 kilonewtons. I'm thinking about, you know, one human equals approximately 1 kilonewton. So think about it in proportions like that. That can kind of help you, give you some background there, right? Um, but the nice thing about an oval is that everything kind of wants to sit now in this middle portion here where it's a circle. And so it's less likely to end up in that weird tri-load situation because everything's going to want to sit towards the center of that arch right there. Um, and in the end, like, the oval is not good at any one job, but it is kind of like able to do all the jobs. So I carry around a lot of ovals because when I'm rigging and stuff, like, this guy can be oriented in a lot of ways and can meet a lot of uses. So that's just a thought there of like where you would use an oval. So I know folks have trouble like identifying the shape differences and stuff. So, but like, this is D, this is considered oval. I have another oval here that I also really like. And so this one looks a little bit more ovally. Sometimes your ovals don't look super round, but this is a more round one. Um, Now you'll notice on certain carabiners that there's like the rounded here area, and I guess they kind of make them into like a little bit of an I-beam type shape, and that's to like shave off a little bit of weight between that. So this is considered a round stock carabiner where it's round all the way around, and then this style of carabiner is trying to shave off a little bit of weight. I don't think it matters that much in the end because as a caver, I jam these things full of mud. So like round stock or not, like ultralight carabiner, they end up heavy to me anyway. Like saving a couple grams, like pick a carabiner you like, right? So so that's just something to think about. Again, this one's a full round stock here because it doesn't have that groove where it tried to shave off a little bit of weight. Again, I just pack that full of mud anyway, so it weighs the same. Um, so that's something to think about. So D oval, and then this is an HMS. So like these are like the three main shapes that you'll see around. And I see a lot of people use HMSs for like their short or sorry, their cow's tails and stuff. I think that's kind of a little bit okay, yeah, it's got a big, wide head here. So like I see why people do it. But we talked about how the spine is where the carabiner likes to hold most of the weight and load. The HMS actually stands for something in German where it's basically like Hauptmunter something, right? And what that means is it's a half clove hitch carabiner, and it was designed specifically for munter hitches. And you can see on my carabiner here as a blue carabiner, it's got some wear marks where the paint has worn off, and you can see that on that end too. So it's right there and right there is where the rope has worn. And so when we're putting in a munter hitch, so the munter hitch runs along the carabiner um, in those two spots there. And what's that's doing here is, this narrow end was meant to be the anchor. But as this rope has two contact points on the carabiner, it's preventing that tri-load by having this wide pear shape. And the force is along this imaginary axis down the center, so it's loading these two legs because of that wide head. um and that's sort of really why this shape of carabiner was developed. So this carabiner is great for doing munter hitches, and I highly recommend getting a couple HMSs so that you can do like really nice munter hitches. One thing that is troublesome though is if you're going to do that munter hitch and end up using it on a D. You see how the D kind of has a little bit of a wider bottom and like the top has this angle to it. What unfortunately happens when you do a munter hitch on this is it likes to pop over this shoulder right here and then it gets stuck, right? So that's actually sort of the difference between an HMS and a D, if that sort of makes sense. Okay, cool. So that's sort of the three main shapes what we've got there for like carabiners. And you can see I like locking carabiners. I naturally just seem to have a lot of these guys. Um and for personal gear and for rigging, realistically you want it to lock so that it closes that opening point there. One thing to kind of think about is when you're rigging, having your carabiner um, in the direction where your gate is not facing a piece of rock that might jam into it and get into that gate. Similarly, you want that strong spine sort of hanging off of your hangers. Um, and on top of that, you want it to screw downwards because as you're climbing rope, it's going to vibrate a little bit. and that vibration will continue to allow this to screw down. Whereas if it was vibrating and you got a little bit of wobble here, and maybe this was up against a piece of rock, or maybe it was just a little bit of loose, or there was some dirt in it, you don't want this to accidentally wobble open. So generally when you're rigging and stuff, you want this to screw downwards and be facing away from any sort of obstructions, so that as you're climbing that rope again and it's vibrating, it tries to stay in that sort of closed position. Uh, Sort of all makes sense-ish. Okay. In NCRC, they've been wanting more and more that we use locking carabiners on our cow's tails. I have seen where people use these like spirit carabiners on their cow's tails, because they're like, yeah, I mean, it's got this bent gate. I can clip it super, super fast. Yeah, that's a great phrase. Screw down so you don't screw up. um, you know, so these non-lockers, yeah, sure, you might clip into something super, super quick. I found that I don't super love it because it also unclips super, super quick. So that's a personal preference right there. And in the case of uh, like rescue training, there is a huge preference to have locking carabiners, because it's not just your life on the line now, it's also like lives of other people around you. You also don't want to become a victim in like a patient in the middle of, trying to rescue somebody. So like lots of reasons where we like lockers. We keep these guys around for demos though. So yeah, these clip super quick. Any sort of questions around that? Obviously we like to do test rappels and stuff like that, so that if this was on your gear, you wouldn't accidentally cross load it, or be on the gate, or unhook from it. I am gonna show you guys last little thing about personal connectors, right? So this is my personal micro rack. I personally use a malleon on it. It can still be removed for that reason. However, a locked malleon is, again, super duper strong, right? Let me see if I haven't worn out my. It is 25 kilonewtons. When it's locked. Now, the thing to note about malleons is their strength rating is based on it being locked, and the thought process is being wrench tight. But basically, I like this option for my personal micro rack, because I don't like the idea of accidentally rolling out of a carabiner. Um, so that's my personal micro rack. I have a twist malleon on my full rack, so that it has that 90-degree twist on it. Micro rack was meant to be operated front and back, but full rack was actually meant to be operated sideways, because then I'm, not limited by hitting my face with my rope as I'm braking. So that 90-degree twist malleon lets me operate my full rack left and right instead. So that's that. Bobbin. This is my personal bobbin. There's a lot of right ways to attach a bobbin, but a malleon is not okay on a bobbin, because malleons are small enough that they will slip through the opening gate on a bobbin. So a bobbin must always use a carabiner. In this case, I've got a little keeper bar on mine that basically doesn't let this move past a certain point. That helps my brain feel happy more than anything else. You still test rappel always, right? But it helps my brain feel happy, because my bobbin's not slipping over onto the gate of my carabiner. That's the only thing that thing's doing. And there's lots of good connectors that you can use for a bobbin. Petzl the Freno. Some people like it. I find that it wears the front plate of my bobbin in a way that I don't like it. So I don't like the Petzl Freno in a personal way, but every bobbin does need to have a breaking carabiner. The Freno is one of them. A regular carabiner is a good option, and actually that's why I had these Petzl Spirits around. Is that this makes a pretty decent wear carabiner, and you can clip your rope into it super quick as your breaking carabiner. And again, bobbins always have to have a breaking carabiner, right? So that's a thing. My personal breaking carabiner that I'm using these days is a Raumer Handy. It comes with this little quick link right here. But it's stainless steel, so it lasts a little longer. It doesn't wear as bad as a regular carabiner, aluminum carabiner might. And there's pinchy end, which helps give you more friction, and you can flip it to the other side, which is less pinchy end that gives you a little less friction for your braking. So it's got two options on it. And this guy makes me pretty happy. So this is my personal brake carabiner right now for use with a bobbin. Um, this has this Raumer Handy basically was designed just for bobbin use. I don't think there's any other use for this guy though. So that's a little bit about that. Obviously you've got D-ring connectors on your personal gear. There's several good options for it. There's D-Mallions, but I'm personally using a Petzl these days. There's an auto locking version of this as well. Just always double check that your auto lock did auto lock. So yeah, that's about what I've got for connectors. Um, any questions on anything related to carabiners and stuff? Got dirt everywhere. Cool. Yeah, I think that's about it in terms of what I had to share. If you have any questions or concerns, happy to answer any other questions. Is there any issue with using a D-ring to tie a rope into a bolt? Are you talking about a D-ring like your central connector on your personal gear, or are you talking about like a D carabiner? Oh, so using your central connector as an attachment point. Um, I don't know. I've never tried to do that. I think that the only thing about the D-ring is that it's specifically designed, like we talked about the weight being along the spine of your carabiner for the most part. So if I look at this guy, I want the weight of my anchor to be, in here, right? So that I'm loading along that spine. And the way that these D connectors, like these central connectors for your personal gear are designed is like your weight's hanging off of this, right? Because like any gear that you're using is going to center itself along the top end of this. So like effectively this is the spine, this curvature. And if you were to put this into an anchor somehow, you're loading the gate side of it. So I actually don't know how that would work. I guess effectively what that turns it into, so the rating along the gate is what you would be looking at. And I don't think that was the use. Like if you read the manufacturer's manual for it, they probably say specifically like this gear was made for your personal frog harness. So you'd be going against what the manufacturer wants you to use it for. So it's like an unspecified use. And like you're kind of skirting the rules versus what the manufacturer designed it for. I don't really have any advice on doing that. I don't think you would want to. Plus, this is like a 20 something dollar connector versus like a regular carabiner is probably around $15. So I don't really see an advantage to doing that.
Is the Dalium the only thing you use when it comes to securing your rack?
I didn't really hear the question. Can you speak up?
Yeah. For your rack, when you secure it with the Dalium, is that your preference or is that basically the standard?
So it is my preference. I would say that if you are test repelling well, um, a carabiner is probably an okay way to do it. However, like I have a very strong preference to using a Malian, because like there's been enough ACAs, like American Caving Accident reports of fatalities from cross loading a carabiner, that I don't think it is an impossible way to, you know, get hurt. So
Actually, that reminds me of a question that I had, Stephanie. I don't know if you can hear me very well, by the way.
I can hear you. Yeah.
Awesome. So I actually saw someone using, I think it was called like a dog bone, if you know what I'm talking about, like for climbing. Um,
Okay.
they were using it as like a connection from their D-ring, like that central connection device to all their gear,
Hmm.
to their micro rack. But to
Okay.
me, it didn't seem safe, but that was just my opinion. So I was wondering if you had any opinions on that.
I've I've not seen a dog bone used before, so I'm not sure. Um, what what I do have to like caveat all of this with is if you buy a specific rack specifically from Petzl, Petzl's manual for their micro rack specifically states to use a carabiner. So if you were to use that Petzl rack, um, and used a Malian with it, you would be going against the manufacturer's recommended use. I don't think that's what I would want to like. I don't know. Like I don't I don't think I would like go against what the manufacturer says, but I don't love the idea personally of using a personal story. How about that? Like let me just get right to it. My first practice doing vertical at the Eden Park wall, I had a rollout on my micro rack using a carabiner. Um I will say that it scared me. I was like, 2 or 3 feet off the ground, but it happened. So I've had personal experience where, yeah, like I was super new and I didn't know what I was doing, obviously, but it is a it is a very possible error to actually happen. And with racks having as long of a fulcrum as it does, like the lever arm of the length of a big metal bar like that, it is not impossible to either roll out or cross load a carabiner. So I am very personally cautious about it because I have personally experienced that. Again, like it was very, very early in me learning vertical. So, I may be overcautious about it. And I was also in my most error prone state. Take that with a grain of salt, however you want to do it. But yeah, my personal gear, I have a Malian on it. Other questions? All right, cool. Hopefully informative, and not too repetitive of things you guys already knew, but feel free to reach out if there's other questions or concerns. Um, but hopefully you guys got something out of out of the discussion. And have a good night. And if you guys have topics that you want us to talk about in the future, like I may not know everything, but we can find somebody who knows about the subject. So let us know if you've got subjects you want to learn about. Cool. Thanks, y'all.
Thanks, Stephanie.